Today we'll be doing the integral from 0 to 1 of the arctangent of x quantity squared dx. And to start off, we will use integration by parts. So we'll let u equal the arctangent of x squared, which means that du equals 2 arctangent of x over the derivative of arctangent of x is x squared plus 1 dx. And dv equals dx, which means that v equals x. So we have a arctangent of x squared times x minus the integral from 0 to 1, and then this evaluate from 0 to 1 of v du, so 2x arctangent of x over x squared plus 1 dx. So we have a arctangent of 1 is equal to pi over 4. So that means the arctangent of squared will be pi squared over 4 squared, which is pi squared over 16. And putting in 0, we have arctangent of 0 squared times 0, which will result in 0. So we have a pi squared over 16 term minus the integral from 0 to 1 of 2x arctangent of x divided by x squared plus 1 dx. And we'll make a substitution. We will let r equal to x squared plus 1, which means that dr over 2x equals dx. R1 will be 1 and R2 will be 2. And the arctangent of x, well, if we solve for x, we have r minus 1 square root equals x. So we have arctangent of x is equal to the arctangent of the square root of r minus 1. So we have a pi squared over 16 minus the integral from 1 to 2 of 2x arctangent of the square root of r minus 1 divided by r and dr over 2x. So as you can see, this 2x cancels. We're left with the pi squared over 16 minus the integral from 1 to 2 of the arctangent of the square root of r minus 1 divided by r dr. And we will use integration by parts again. So we will let u equal the arctangent of the square root of r minus 1, which means that du will be 1 over 1 plus the square root of r minus 1 quantity squared times the derivative of the square root of r minus 1. We'll have a 1 over 1 plus r minus 1 times 1 over 2 times the square root of r minus 1. As you can see, these ones will cancel. So we have that du equals 1 over 2r square root of r minus 1. And dv will equal 1 over r, so that v equals the natural log of r. So we're going to be left with a pi squared over 16 minus brackets u times v, which is a arctangent of the square root of r minus 1 times v, the natural log of r, evaluate from 1 to 2, minus the integral from 1 to 2 of v du. So we have a natural log of r divided by 2r times the square root of r minus 1 dr. So we have a pi squared over 16 minus, we have an arctangent of 1 term, so we have a pi over 4 and a log 2. And plugging in 1, we have an arctangent of 0 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over 2 times the natural log of 1, which will end up being 0. So minus the integral from 1 to 2 of 1 over of the natural log of r divided by 2r square root of r minus 1 dr. And distributing the negative signs, we have pi squared over 16 minus pi over 4 log 2, and plus the integral from 1 to 2 of the natural log of r divided by 2r square root of r minus 1 dr. And we would make another substitution. We will let s equal the square root of r minus 1, which means that s squared equals r minus 1, which also means that s squared plus 1 equals r, and that dr equals 2s ds. And we have that the natural log of r equals the natural log of s squared plus 1. So we're going to have a pi squared over 16 minus pi over 4 log 2, and then plus the bounds, I forgot, s1 will be 0 and s2 will be 1. So from 0 to 1 of the natural log of s squared plus 1 divided by 2r, which is s squared plus 1, and times an s, and dr is 2s ds. But as you can see, this 2 cancels and this s cancels. So we have a pi squared over 16 minus pi over 4 log 2 plus the integral from 0 to 1 of the natural log of s squared plus 1 over s squared plus 1 ds. And then from here we will use substitution. So we're going to let s equal the tangent of theta, which means that ds equals secant squared theta d theta, and that s squared plus 1 will be tangent squared plus 1, which is the secant squared theta d theta, and that notice that ds over s squared plus 1 is equal to secant squared theta d theta over secant squared theta, which will just end up being d theta. And the bounds of integration, theta will equal arctangent of s. So theta 1 will be 0 and theta 2 will be pi over 4. So we have the following. We have pi squared over 16 minus pi over 4 log 2, and then plus the integral from 0 to pi over 4 of the natural log of s squared plus 1. We said it's secant squared theta, and ds over s squared plus 1 is just d theta. So we have a pi squared over 16 minus pi over 4 log 2. We can rewrite this as plus twice the integral from 0 to pi over 4 of the natural log of the secant of theta d theta. And we'll notice that the natural log of the secant of theta is the same thing as the natural log of 1 over the cosine of theta, which is negative the natural log of the cosine of theta. So we have a pi squared over 16 minus pi over 4 log 2, and plus twice the integral from 0 to pi over 4 of negative the natural log of the cosine of theta d theta, which we have a pi squared over 16 minus pi over 4 log 2 minus twice the integral from 0 to pi over 4 of the natural log of the cosine of theta d theta. And I already did a video on this particular integral, and this integral will result into negative pi over 4 log 2 plus 1/2 of Catalan's constant. So using this result, we have pi squared over 16 minus pi over 4 log 2 minus twice of negative pi over 4 log 2 plus 1/2 of Catalan's constant. So we have a pi squared over 16 minus pi over 4 log 2, and we'll have a plus pi over 2 log 2 minus Catalan's constant. But from here, I could get a common denominator by multiplying both sides by 2 here. And we'll end up with pi squared over 16 minus pi over 4 log 2, and then plus 2 pi over 4 log 2 minus Catalan's constant, which simplifies into a pi squared over 16, and then a plus positive pi over 4 log 2 minus Catalan's constant. And so this is the final result to the desired integral. Thank you very much for watching.